the center that he's founded and is driving. So as Chintan said, the title of the talk is Connecting the Next 3 Billion. I'm going to start by telling you a little bit about why we're interested in solving this problem. So our mission as a company is to create solutions for places that don't have good wireless coverage today. Now, there's an assumption underlying here that every wireless service provider would like to take out the magic marker and color in the entire map and just be done. And so you, as a customer, had coverage everywhere. That would be great for them. The only reason they don't is because current technology doesn't make it cost-effective for them to provide coverage in certain places in certain situations, like inside of buildings, in tunnels, on ships, in rural areas. These are all areas that are hard to cover because the economic model of the equipment and network architecture that was built to, cover Manhattan and London and places like that doesn't work so well in these areas. So, and there's another reason behind this philosophy. How many of you guys are familiar with Clay Christensen's work, The Innovator's Dilemma at Harvard Business School? A good number of you. We're very fortunate to have Clay on our board, and we really try to follow his philosophy in terms of disruptive technology and entering new markets. And when you look at the wireless infrastructure industry, it's dominated by a very small number of very large companies. You probably know them, Ericsson, Nokia, and the two Chinese vendors, Huawei and ZTE. That's about it. They're each tens of billions each. And the question is that a lot of Clay's work addresses is how does a small company not only enter this market, but eventually upset the apple cart? And a key part of the thesis is that you can't really go head-to-head with these guys. If we had the same product portfolio in terms of functionality that Ericsson and Huawei did, we'd never have the reputation and installed base of Ericsson. We'd never be cheaper than the Chinese vendors, so we'd kind of be out of business. So the way Clay describes it is you want to compete against non-consumption. You want to find a place or a market where people aren't using that product or service because it's either too expensive or it's too complicated or the economics don't work. And that's effectively a greenfield market that you can go own. And we've done this now in a couple cases. One area of, which I won't really talk about today, but happy to talk about afterwards, of terrible coverage is in-building coverage. And it's really, really bad in the high-growth developing markets like India. If you've ever been there and tried to use your cell phone inside of buildings, it's terrible. And we attacked that solution, ironically, initially with Tata Teleservices in India and now with Vodafone. And we have over 1,000 units deployed with them. Another challenge that we took on was rural coverage in the U.S. If you have a ski house in Vermont or New Hampshire, you know that there's no coverage once you get off the major highways and the big cities. And again, it's economics. You have low population density, so the amount of revenue that you can get from each of the cell sites is less. That, I won't talk about that either, but if you want to learn more, it's a subsidiary called CoverageCo, www.coverageco.com. And we have 200 sites live in Vermont, and now we're expanding the network to 500 sites. And we have a viable economic model for coverage for rural areas, and we support T-Mobile, Sprint, and Verizon currently. But in looking, so we segmented all the places you don't have coverage and looked at them, and in-building in India was one of the first ones we looked at, then the rural U.S. But by far, the biggest unaddressed wireless market is the rural developing market. In the developing markets, you have a lot of good coverage in the urban areas. You go to Lagos or New Delhi, it might be tough because there's so many people and networks are jammed, but you got coverage. It works, and so there's very robust business there. You get outside of the cities, and you got very, very little. Now, in terms of the addressable market, there's a lot of misinformation out there, and I'm going to talk about that. You've probably seen statistics, like there are over 6.5 billion mobile connections in the world. And you say, wow, there's 7 billion people in the world. We're almost done. Not the case, and here's why. So while there are over 6.5 billion SIM cards issued, right? These are SIM cards, not mobile connections. Now, in most of the world, unlike the United States, it's all prepaid. And about 10% of SIM cards are inactive. They're discarded, thrown out, lost, whatever. But more importantly, globally, users have an average of 1.85 SIM cards each. I mean, here I've got one in my phone, my Kindle, and my iPad. But it's different in the developing market, and it's actually greater. In India, the average SIM card per person is per cell user is 2.6. And what it is there, it's all for their one phone, but they arbitrage. This provider gives me free calls from 5 to 7. So from 5 to 7, that SIM card goes in my phone. This one gives me discounted rates late at night, so that one goes in the phone. And this one, and one of the providers we work with got kind of stung by this. They had a promotion where you got 200 free minutes. People bought the SIM card, used 200 minutes, and threw it away. So when you add it all up, the 10% inactive, the 1.85 average SIM per user, only 45% of the world has a mobile phone today. And that is a much more realistic number. And this company I've referenced here, Wireless Intelligence, I think they're the only ones who do this market research right. But to tell you how pervasive this SIM card equals mobile subscribers notion is, there's a report you can Google out by the UN. It got a lot of publicity, I think, last year. And it's actually addressing a very important point, so I don't mean to minimize that. But the data underlying it isn't quite right. But the headline of the report was, hey, we're not focusing on the right thing. There are more mobile phones in the world than there are toilets. And it's true that lack of toilets in places is a real problem. In fact, there's an election going on now, and one of the election stumps for the guy who's projected to win was a toilet in every home. We used to have a chicken in every pot. They have a toilet in every home. But so it's a problem. But they use the 6.5 billion number and say there's only 4.5 billion toilets. But to give you an idea, that was done by the UN, and that's how pervasive the thinking is that everybody has a cell phone. It's simply not true. So, but the question is why? Why don't they have cell phones? Well, if you look at the challenges in covering, I noted rural Africa, but this is rural any developing market. Number one, you don't have power. Most of the people who don't have cell coverage, it's because there's no power grid. A traditional cell site, you've seen the towers along the highway, takes about 2 kilowatts of power to run. You can't run that off alternative energy. So to the extent any cell sites are built in rural areas, they run 24/7 on diesel fuel. A little more on that later. Another one is there's no telecom infrastructure of any kind. The dirty secret of wireless is that it runs on top of the wired network. To every cell site, there's T1 lines or maybe now fiber running to the cell site, but there's a high bandwidth wired connection to that cell site. We don't have the wired infrastructure in these rural developing markets to build the cellular network on top of. You're starting from scratch. Another big one is you don't have skilled labor out in these rural areas, and traditional wireless infrastructure systems are very complicated to set up, configure, and maintain. And so that's been a challenge. And then finally, the big economic challenge is, here in the U.S., average subscriber revenue per month is over $50. In these rural areas, it's going to be $1 to $3. So all of a sudden, if you build the same network and the same cost structure, and your revenue stream goes down by over a factor of 10, guess what? It doesn't work. And that's the fundamental reason people don't build these areas, because trying to build it the conventional way, your operating costs every month are more than the revenue that you could make. But there is a real opportunity, and there's a bit of a chicken and egg problem here. This study that I referenced at the bottom was done by the GSM Association on rural villages in India. And the study concluded that for every 10% increase in mobile penetration in a rural Indian village, the village GDP goes up by 1.6%. That's for every 10%. Now, to put it in perspective, last quarter the U.S. GDP grew by 0.1%, and we were all thrilled that it was a non-negative number. You can get 1.6 and another 1.6 on top of that just by getting the 20% increase in cellular penetration. So the chicken and egg is people say, oh, well, they're working on a few dollars a month, they can't afford cell phones. You bring them cell phones, you increase their earning power, and they can afford it. So there's a little chicken and egg, and you got to go build it a little bit on faith that it will work and the economy will sort of bootstrap itself. And there's some good anecdotes of this. There was, a lot of skepticism that people could afford a cell phone and afford a monthly plan. And there's a story about a plumber in an Indian village. Now, one of the things you have to realize is we're not bringing just mobile or internet to these areas. We're bringing the first electronic communication of any kind. We're talking about areas that are basically in a pre-Alexander Graham Bell state. They have no landlines. For example, in India, it's 1.2 billion people. Even today, there's a total of 30 million landlines in the country. So pre-cell phone, 30 million out of a billion people had voice communications. But to give you an idea of how the economic impact of cellular plays out is the anecdote that I heard about a plumber in India. He was one of the 30 million who had a landline. So he would go out and do a job, come back to his office, pick up his message, go out and do the next job. Now that he has a cell phone, when he's at the job, he gets a call and goes directly to the next job, directly to the next job. Before the cell phone, with the travel to and from the office, he could do 3 jobs a day. Now he can do 7. So he more than doubled his income because he had a cell phone. Of course he can afford a cell phone now. So there's real opportunity if you can figure out how to build this profitably. So let's talk a little bit about the traditional approach to building cellular networks, and we'll talk about why it doesn't work. So this is a picture of a traditional cell tower in rural Africa. You see it in the background there. Pretty much like you'll see on like I-93 by the highway, big tall tower. Building these things in rural Africa is challenging. You got to transport the equipment, the cement, everything in. It costs about $200,000 to build a tower there. It's not actually that much more. It's $150,000 to $200,000 to build towers here. Big, tall steel structures. But that's not even the worst part. So this is an expansion of what the base of a cell site looks like. So you've got this shelter where all the equipment goes. Remember, it uses about 2 kilowatts of power. You got to air condition the shelter, which takes more power. But then when you're in these rural areas, you've got to have diesel generators and diesel depots there to run it because you have no other source of power. And diesel is a very attractive theft item. I mean, in areas with no power, putting stashes of diesel fuel is like putting little piles of gold out there. And so the problem is you got to have security. So you build the fence and you have to have 24/7 security guards. To tell you how much of a issue this is, last year in Liberia, the security guards at 6 cell sites were shot and killed, and they stole the diesel fuel and the diesel generators. That's how valuable that is and how attractive that is. So in addition to the cost and the environmental impact, there's a big security factor which complicates running it and increases costs as well. So each of these sites burns about 7,000 gallons of diesel fuel a year. And just the fuel itself costs about $5,000 a month. And when you have subscribers who are paying $1 to $3 a month, the math doesn't add up. And that's why. And what happens is governments, and we do it in this country too, they'll issue grants to build rural networks. So to cover that $200K of building the site. So people go out and build the site, but then that gives them the right to lose money on running that site every day. And you'll find, we found this in Nigeria, we find sites that were subsidized by the government built, they don't operate. They can't afford to fuel them. So they just don't run. So diesel has another problem, which is a major environmental impact. So there's been a study by the IHS Group, which is a big African tower company. They own a lot of towers in Africa. And they figured to cover rural Africa, it would take an additional 60,000 towers. It seems like a reasonable estimate given what we have in this country in terms of coverage. So if you think about that and you have 7,000 gallons of diesel fuel at each tower in rural areas per year, you're going to burn 420 million gallons of diesel fuel a year. So in terms of cost and environmental impact, that's huge. But it's actually worse than that. There was a very good study done, which was published by Reuters, which talked about the logistics in deep rural areas. And transporting the fuel and all the supplies out there is expensive, and you actually burn more diesel fuel in the truck getting the diesel fuel to the remote site than you do at the site. So if you take that into account, now we're talking about 840 million gallons of diesel fuel a year. That's what, $4 trillion in diesel fuel if you did it this way. And the environmental impact would be absolutely disastrous in these areas. So, people still try to just take the network they know how to build and push it out in these areas, but if you step back and look at it, for a lot of reasons, it's just not going to work. So we've looked at it and figured out a better way. So I want to make a comment here, since this is the focus of the center, about the term frugal engineering, which Tintin and I talked about a lot. How many are familiar with the term? Okay. I don't like it because it gives the wrong impression. It gives the impression you're trying to do things on the cheap. And that's not the right way to solve these problems, because cheap stuff is going to go out there and fail and break. What I think it is being really frugal about your requirements and focusing on the ones that you really need to make it work in these areas, and just completely giving up on other requirements that might be nice to have features or things that have been in networks for 20 years that everybody expects to see there. If you can't meet the power budget or the, any of the other constraints, you've got to drop it. And I'll give you a specific example of this later and talk a little bit about why it's a rational decision and why it's so hard to convince wireless carriers that this is the right thing to do. So let's look at what traditionally wireless research is about. So here are the sort of leading research goals from two of the leaders in wireless research, Ericsson and Qualcomm. So Qualcomm's stated goal, and what their whole R&D department's focus on, is improving the efficiency of our spectrum use by a factor of 1,000 over, I think it's the next 10 years. It's a very, very ambitious goal, and it's a very important goal. So I don't mean to diss these goals in any way. They're critical. If you look at the growth in wireless, the expansion of data rate per user in crowded urban areas, we don't have enough spectrum to meet the demand. Even if we sort of took it all we had and gave it to a couple of providers, you still wouldn't meet it. So you need to be more efficient, and that's really important. But it's a very urban-focused goal. And you look at Ericsson with their goals for 5G, they're trying to get a gigabit to each user. That's great. I would like that. I could use it today. Very, very useful. But let's think about these in the context of the rural developing market. So in the areas we're talking about, there's no coverage today. Their current spectrum utilization is 0 hertz. So 1,000 times more efficient on 0 doesn't really get you much. It's not the right goal, right? You've got to get connectivity there, not be more efficient. And in fact, you can be inefficient to start because you actually have more spectrum than you need. It's a very different scenario than what we're dealing with in urban areas in the developed world. And the data rate is an interesting one. As you know, there's a bunch of very high-profile companies trying to bring internet to the developed world, and they're all about bringing a gigabit or 100 megabits to each user, which would be good and useful, but if you step back and think about it, okay, they can't even make a voice call today. And if getting them a megabit is hard, getting them 10 kilobits would be amazing. When we first got 14.4 modems, it was really, really great because we didn't have anything. And there's a great story that illustrates this from the telecommunication minister in Zambia. And he said, look, just because we got areas with no coverage, don't think that people don't have cell phones. And he told a story about a village that was a 4-hour drive to the nearest cell coverage. But he said, most of the people in the village have a phone. And what they do is every morning, they all give their phones to this one guy who has a truck. And he drives 4 hours to the cell site, turns on the phones. They all upload any stored text messages, download voicemails and messages from the network. He drives 4 hours home, and in the evening, everyone checks their messages. And you may think, oh my gosh, once a day. Well, maybe you think it's good that you can only use your cell phone once a day. But, your communication bandwidth and latency, it's just terrible. But when you think about it, if somebody comes back and he has one text message on his phone, well, without doing this, he would have 0. So that's an infinite increase in their communications capacity. So 1,000x nice, but infinite is a lot better. And if you think of going from nothing to something, that's the most important thing to do, not how good the something is. We can do that later. And once you give them something, that will improve the economy. People will be able to afford more. You'll be able to invest in improving the network at that point. So we can't get distracted by thinking it has to look like the network's here in order to be useful. Another example is, a lot of these areas you get GSM voice and SMS, but no data coverage at all. And what have people done? They've written little apps on their flip phones that allow them to do Facebook status updates over SMS, because that's all they have. And they're using Facebook. It's really, there's a lot of innovation going on with whatever they have. So here are the most important requirements if you're going to attack the rural developing market. And you'll notice none of them were on this previous slide. Number one is low power consumption, because you've got to run off grid. You can't do diesel for all the reasons talked about. It's got to be alternative, wind, solar, something like that. You really have to be under 100 watts for the site to make it feasible to run on alternative power. It's got to be outdoor mountable. You can't afford shelters and air conditioning. You got to bring something out, stick it on a wall or stick it on a pole, and just be done. Because of that, it's got to be small size and weight. You can't afford, part of that $200K cost per site is shipping all the steel and concrete out to these remote areas. You ideally want something someone can carry under their hand or stick in the back of a pickup truck and go install. And because of the lack of skilled labor, you have to be able to remotely monitor and maintain these sites to the maximum degree possible. You can never do it completely remotely. I mean, if lightning hits the site and something falls off, you got to send someone out there. But anything else, you want to be certainly able to detect remotely and fix as much as you can remotely. That's very, very important. So I'll give you an example now of taking those requirements and making an engineering trade-off against typical requirements. So receive diversity is a feature where it's been in cellular networks for decades now. You have multiple antennas. It started with 2, and now with MIMO it's many. So you receive the signal on multiple antennas, and because they're at different physical places, even separated by a small amount, you get different signals, and you can combine them and do a better job at receiving the signal. You can increase the range that you can get signals at, and you can also be much more robust to interference. It started in the GSM in the 90s, and it's in everything now. It's being expanded. It's a great way for increasing range, capacity, and interference robustness. But when you take each of your antennas and make them both transmit and receive, you have to put something called a duplexer in there, which separates out the high-power transmit signal, which might be like 10 watts, from the really low-power receive signal, which might be a milliwatt, and clearly isolate them. So you stick in the duplexers, but when you stick something like that in there, you have loss. So you have a 3 dB loss in power, which equates to a factor of 2 in power. So now to have the same output power, I need to crank up my transmit power by a factor of 2. And the power amp is by far the most inefficient part of the base station. It's about 25% efficiency. So you've probably gone up your overall power requirements on the base station by a factor of 1.8. And now, just to do receive diversity, which gives me a little more range and a little more interference robustness, I've screwed up my number one goal. And when you think about it, okay, more range would be nice, but if I'm talking about no coverage versus some coverage, I'll sacrifice that. And the interference robustness isn't really useful at all until we get so many of these things out there that you actually have lots of interference. And at that point, hopefully the business is going well enough that you can invest in upgrading the network. So, it seems rational, seems very rational to us that, hey, power is number one, we got to optimize this. I can't tell you how hard it is to convince wireless carriers that this is the right thing to do. And the typical process is you go talk to a carrier, and we just got this last week from a carrier. First thing they do is, here's our requirements for our wireless network. You get a 70-page document. And you have to go through and check off the box on everything that you comply with. And of course, there's a bunch of things for this product we don't comply with because we've made trade-offs like this. And they'll come back and say, what do you mean you guys don't have diversity? Everybody has diversity. It's been in networks for 20 years. You must have some really backwards technology here. And they're so, what they want is all the requirements checked and then lower power, lower cost, lower size. It just doesn't work that way, right? It's a zero-sum game. So it's really, really challenging to break the entrenched mindset on this is how networks were built. And at the end of this, I'll tell you how we're getting around that. Another factor where we get a lot of, you guys are so backwards kind of looks, is choice of wireless standards. Everybody's pushing to 4G here. A lot of the world's going to 3G. But if you look at the blue on this graph, that's GSM. And if you look at the areas we're going in, Asia-Pac, Middle East Asia, Central and Eastern Europe, Latin America, they're dominant GSM. And I believe will be for a while. So the reason, and if you look at it, most of you probably have LTE-capable phones. Well, you're about the only people in the world who have that today. And if you look at India, I think is a good bellwether for where this is going. Several providers have invested billions of dollars in building 3G networks in India. They're pretty well covered in 2G. And it's been many years, not quite, maybe 8 years since they've done this. Less than 5% of subscribers in India are 3G. Okay, it's about 97% GSM still. So you got to ask why. So one thing is, people always point out, the phone cost is more expensive and people are investing in building cheaper cell phones. That's a little bit of a barrier. I don't believe it's the bigger one. What you find in these areas is people will save up 6 months to buy a cooler phone because it's a status symbol, right? So they're willing to save to do that. It's kind of like, you guys probably aren't old enough to remember Air Jordans, but the $100 sneaker, the Air Jordan, that poor kids were buying, and they couldn't be seen without them. It's the same thing. You'll save up for the status symbol. But what happens when you get a 3G phone? Your usage cost per month goes way up because now you have a higher bill for data. That's unsustainable. People can't afford a higher monthly nut. And the other factor, which is, it matters even in urban areas, but really matters in rural, is your 3G phone, your smartphone, the battery life ain't that great. You can get 2G flip phones and still last 3 days. And when you don't have access to power, that's really, really important. There was a study, I tried to dig it up, I couldn't find it, but I saw by a university in Zambia, and they did a study on cell phone charging in rural areas. And they concluded that people in rural areas with no access to power walk between 4 and 18 kilometers twice a week just to charge their phone. And not surprisingly, 87% of those surveys responded that if it was closer, they'd do it more often. So battery life is really important. And so for all those factors, and I think the monthly recurring cost being the biggest one, there isn't good penetration of 3 and 4G. But that doesn't mean there isn't a need for or a use for data in these areas. And there used to be a thinking that, most of the people in these areas are illiterate. And so what are they going to use data for? And I used to think that. And I remember I met with the CEO of Airtel, who's the biggest provider in India. And he said, yeah, we built out Bihar, which is the second poorest state in India and has tons of illiteracy. And he said, we didn't think there would be much data use. And at first, they just rolled out voice and SMS, no data. And not surprisingly, there's very little SMS traffic. It's hard to send a text if you're illiterate. But then, as they upgraded the network, they all have some data capability, GPRS or Edge. And it was out there. And they said, we started noticing tremendous data uptake in Bihar. In some cases higher than some of the other areas that were more literate. And the conclusion, for those of you who've been to India, you'll understand this, was that you don't need to be literate to point and click to download Bollywood film trailers or cricket highlights. And those were dominating the traffic. And remember, they don't have any other media to get it. So they were just sucking it down at tremendous rates. So I believe there is a need, a market for data, but delivering it through 3 and 4G is the wrong business model. I believe the answer is Wi-Fi. And the reason is that Wi-Fi devices are cheaper. You don't have these monthly plans or higher monthly nuts. You can get a scratch card, and the per gigabyte rate on Wi-Fi is actually pretty reasonable. And you also have, you have a wide variety of low-cost devices with good battery life. The Wi-Fi only pads and things are pretty good. So I believe, and yes, you don't have wide area coverage, you have hotspot coverage for data, but if people are willing to walk 18 kilometers to charge their phone, they'll walk to the village center to connect to a hotspot. So we believe the solution is GSM for voice and data, that's sort of the underlying global language for cellular, and Wi-Fi for data. So having looked at all this, we decided, all right, we better go design a product to do this. And we designed a product called the Compact RAN. Now, it does 2 GSM carriers, so it's what's one of these units could support, based on calling patterns, a subscriber base of about 1,000 people, and it's a Wi-Fi hotspot. Most important thing with the GSM and Wi-Fi and some additional processing, it only consumes 65 watts of power. So it can run off solar. And you see it's very, very small. It's about this big, very light, 7.5 kilograms. You can put it under your arm and go take it out somewhere and tack it up on a wall or on a pole. So once we did this, we said, all right, well, we better go see if we're right about this. So we deployed some sites in Zambia running 100% off solar power. And in Zambia, as you'll see, the majority of the population is rural and have no cell coverage whatsoever. So we deployed the first solar. That's a solar site. There's a little tower with a solar panel next to it. That's the coverage map that we covered. That's the chief of the village, and now he has electronic communication for the first time in the history of the village. They've never had a telephone. They've never had an internet connection, nothing. And now they have it all the way back and can communicate with anyone in the world. And so, largely this was a success. It worked. But you always learn something from the trials. And we learned 2 things that were very interesting. One was most products of this ilk are spec to go to 45 degrees C, which we said, no, we're going to be outdoor in rural Africa. We better go to 55 degrees C. That's actually 132 degrees Fahrenheit. Now, even if it doesn't get that hot, with the sun beating down on it all day, it can heat up. We thought, hey, 55 is pretty good. Well, we lit these sites up in July. In August, there were 5 days where the temperature trigger actually tripped and shut the unit down because it got over 55 degrees. So we went and redesigned it, and now we go up to 65 degrees. The other thing we learned really changed our whole business model and go-to-market strategy. So, this is where we really learned about the charging problem. Even if you have coverage, if you can't charge your cell phone, usage is going to be low. In addition, one of the things that we learned was, while people are spending $1 to $3 on their cell phone per month in these areas, the way they charge is they go to a shopkeeper who lets them plug in their generator, or some enterprising person has a camping generator and they'll charge people. They're spending $3 to $5 on charging their cell phone. And, one of the challenges about doing business here is there's no market research you can go by which tells you these things, because nobody studies markets that don't exist. So you have to go with anecdotal data. And we have gone out to these villages. Give me 1 second here. Yeah. We've gone out to these villages and surveyed them. So this is, you can probably tell which are our team members here in the picture. So this is the CEO of our Africa venture looking at site selection. And this guy, Chris Wall, they were so excited about us possibly bringing solar to him, they named him honorary chief of the village. So you got to go in and just learn what's really going on there. So we learned about, and the carriers sort of complain about what they call ARPU erosion to the government. They say, hey, they're only spending $1 to $3 with us, but if you guys build power, there's $3 to $5 that they could move over and start spending on cellular. We looked at it a different way. We said, wow, if we could charge their phones for them, we could capture that $3 to $5. So, and then the other thing we learned, there's a lot of skepticism, especially as we go out and talk to investors, that, well, if you build it, will they come? Is there really revenue there? Do these people have phones? And the one thing, this village, the one on the right, it was 2 hours from any cell coverage. Our team drove out there. When they got out of the car, the first thing everyone in the village did was take out their camera phone and take a picture of it. So they got phones, and they're doing if they can only get coverage once or twice a week, that's still really valuable for them. So we're very optimistic that once you bring coverage there, usage will really, really pick up. So what we did was we created an integrated solution. So this is a prefab pole which has 250-watt solar panel, batteries. We made a choice on the batteries that actually increase cost. We're using lithium-ion batteries because they don't require maintenance for 7 to 10 years. As we went out in these villages, I didn't put that picture up, but one of them, somebody had done a solar streetlight project, and you could see them up on the lamps. And you talk to them, and they say, yeah, those things haven't worked for years. You find out that nobody maintained the batteries, put water in them, etc. It's a skilled labor issue. So the things die. So we said, all right, lithium ion is more expensive, but it's going to help us operate this thing for 7 to 10 years. We have our compact RAM, which gives us GSM and Wi-Fi. But then what we did at the base is a cell phone charging station. And one of the infrastructures that's very robust in Africa is a scratch card infrastructure, whether you buy it for cell phones or anything else. So we're going to have scratch cards that you punch in the number on a keypad and you plug in and charge your phone. And we'll charge 25 cents a charge, which is about the going rate. So now all of a sudden we're enabling them to charge it, which uses it more, but that money they were spending by walking 18 kilometers and paying a shopkeeper, they're going to spend here. So now we can turn these nodes profitable because we have 3 sources of revenue. We have cellular voice, we have Wi-Fi data through scratch cards, and we have charging. And in fact, the way it works is, even if we didn't provide any wireless service, the things would break even just on the charging because it's that valuable. In fact, we've been talking to the government about various programs they have to provide support, grants, insurance for these kind of things. And there's a big initiative by the administration called Power Africa. And they looked at us, they said, guys, I know you're bringing communications, that's what you're excited about, but you guys are really a power initiative. And that's how they saw what we were doing. And I think there's some validity to that. So the other piece is not only engineering the technology, but engineering the business model. The challenge here is, even with our solution, for one provider to build and maintain infrastructure and support just their subscribers, it's a marginal business model. It only gets worse if two providers decided to build a network in these areas, right? That's crazy, because now you're doubling the costs and splitting the revenues. So in an ideal world, what you would have is one infrastructure that any of the providers could use. Think of it as like a toll road in wireless. So, you go on a toll road, lots of businesses transport their goods over the toll road, and they pay a little bit to use the road. So that's what we're doing. And in fact, we pioneered this with our network in Vermont that I mentioned earlier. We don't have subscribers. We provide coverage, and Sprint, T-Mobile, and Verizon, and 4 Canadian providers pay us for every minute or megabyte transported over our network for their customers. So it makes for a much, much more efficient model, because now you're amortizing the cost of one infrastructure over multiple subscriber bases. You also cut out a lot of overhead in the business. In a typical cellular business, there's tremendous overhead on the retail side of the business. When you buy an iPhone from a provider, they're subsidizing that by about $400. They have retail stores, they have customer support, they have all these things that we don't have. So we get a much more efficient business. And the regulators in these countries love it, because what they've been faced with, if someone actually agreed to build rural, which very few people have because it doesn't work, what they're effectively granting them is a monopoly on rural. Right? So one carrier builds it out, the villages are stuck buying their service, and what you end up with is oftentimes the people in rural who make less money have higher cell phone rates than the people in urban because of lack of competition. So by being a neutral host wholesale network, we allow any operator that wants to sign a contract with us and work over the network, so support their subscribers, so we bring competition to these areas. And our argument is that the pricing plans will equalize with the urban areas because the competition is the same. But this is now a very different business. So you've got, before we were thinking, hey, we sell equipment to carriers. That's what we do to Vodafone and Tata in India. Now we're providing a service. So we started a new entity called Banu Africa to build this network and provide the service. This has another advantage that is the one I like even more. I don't have to convince some technology team at a network operator that all these features we cut out were the right thing to do that they're used to having, right? We can decide what the right feature set is and just go do it. So rather than beat my head against sort of the traditional mindset, we said, well, if we're right, we should be able to go around them and just do it. And it's if nothing else, it gives you a lot more peace of mind. So I'll give you a couple slides on our Africa initiative. You can get more information at www.banu-africa.com. And please go to Facebook and like us, because you get lots of things if enough people like you. And so what's our challenge? 274 million people in Africa have no access to cellular coverage. As you see, the vast majority of them also don't have access to power. That's our sweet spot. To tell you how unprofitable it is for carriers to build rural in these areas, the governments, when they license spectrum, often have a requirement that you have to build rural. And there's two ways nobody does, so they enforce it in one of two ways. Most countries have what's called a universal service fund, which actually shows up as a tax on your cell phone bill. And that goes into this fund to support rural infrastructure build. The Universal Service Fund in India has accrued $6 billion, the one in Nigeria has accrued $5 billion. They can't spend it. They offered MTN $2 billion to build rural, and they said, no thanks, because you're just giving me money so that I can lose money. The other way they do it, which is the way they do it in Cameroon, is they impose quarterly penalties if you haven't covered rural. MTN Cameroon is paying an $8 million a quarter penalty for not covering rural. But that tells you, if they built the network, they would lose more than $8 million, right? So it tells you how bad. So the chairman of MTN Cameroon is actually going to be one of the investors in this company, and he's like, you have to come to my country and build it. And effectively, he's got $8 million a quarter for us to work with to go build and run that network. So what are the benefits? So absolutely transforming the network operating costs of the network architecture, going to solar, going to small nodes. These are 15-meter poles. These aren't 200-foot towers, okay? you can't afford to build a 200-foot tower. And yes, we will have more spotty coverage, right? We'll put it in the village and along the roads. You won't get that nice blanketed coverage. But what we've learned, and this is true in Alaska and Vermont, in Nepal and in Zambia, where we build stuff, is if you take a different mindset, which is let's not just try to cover area and color in the map, but let's try to cover where people live, work, and commute. It turns out if you cover the roads, I don't mean highways, but secondary, tertiary roads, at half a mile to a mile on either side of the road, you get most of the places that people live, work, and commute. Most homes are within a half a mile on the road, most businesses. Some farms are more in, but they're a very small percentage. So if you get, you're pretty happy if you have coverage where you live, work, and commute. And we believe we can do that with small cells. So the other thing we're doing that the industry thinks is crazy is there's a big push, you've probably heard about it, for small cells. They're for in-building and urban infill to get better urban coverage. We're covering rural with small cells. The traditional thinking in rural is you got these spread out areas, you want to build the tallest, highest power tower you can to cover the most area. And, as the chairman of Coverage Co, our U.S. subsidiary, is Barry West, who is the CTO of Sprint Nextel. And kind of what got us started on it, he has a rural New Hampshire farm, and we're up on the back porch talking about this. And he said, look, there's got to be a better way to cover rural. He said, I've built lots of these high sites to cover the big area when he was at Sprint and at Nextel. And he said, mostly you just cover more rocks and trees, and they don't generate enough revenue. Mm-hmm. So that got us thinking about where do you want coverage, and it's where you live, work, and commute. And this, in Africa, you get the village clusters, roads going away from it, farms along the road. And again, people are walking 18 kilometers to charge their phone. If they have to go down the street to make a call, not a big deal. So it's a very, very different approach. We've reduced operating costs through the wholesale business model, and we've increased revenue through adding the charging stations. And that's one of the key things that gives some robustness to the business model. So instead of just capturing the $1 to $3 spend of cellular, we're capturing the $5 to $7 spend of cellular plus charging. And that, at $5 to $7 a subscriber, we can make the business model work. So we're going to build and deploy the towers. We don't charge the carriers for that. We do that. And then we run it as a service. Good thing is that's a pretty standard business practice for them. All carriers sign roaming agreements. When you go to Europe, you're on Vodafone. They have a roaming agreement with AT&T and T-Mobile here, and they just exchange charges. So we're saying, hey, we're just doing the same thing. We're not inventing anything new. We're using the scratch card infrastructure for charging and Wi-Fi. And we'll start building the network in another month, and this fall launch in Nigeria, and then follow on Cameroon. Assuming we're successful, we have a plan to go after 33 African countries. You may ask, why not 54? Or is it 55 now? I think it is with South Sudan. I can never keep track. Given political risk, governments, etc., we had to carve the list down a little bit. There's some places that you can't go politically and you don't want to go from a security perspective. But if we can hit 33 countries with 164,000 nodes, we'll cover 164 million people. And that's our goal in the next 5 years.